Today's daily code problem of the day is take k of each character from left and right, number 2516. For this problem, we're given a string s consisting of the characters a, b, and c. We're also given a non-negative integer called k. Each minute, you may take either the leftmost character of s or the rightmost character of s. We want to return the minimum number of minutes needed for you to take at least k of each character, or return -1 if it is not possible to take k of each character. So let's go ahead and look at example 1 here. We have s is equal to AAB, whatever, right? And k is equal to 2, meaning we need to get 2 of each character. 2 A's, 2 B's, 2 C's. That's our goal. How do we do that? Well, we're going to look at the leftmost character, the rightmost character, and say, okay, we don't have any A's or C's, but we're going to take A first. Taking that leftmost A brings us to the next A, so we can take that A. And then that brings us to B. We can take B because we don't have any B's. So now we have 2 A's, 1 B. Alright? Then we're like, okay, another A. We don't necessarily need that right now because we don't have any C's. So we can take C. We have 1 C. And then we see the B, so we take 2 B's. Or sorry, we don't even need a third A. We have 2 A's. So we take B. And then we look and we're like, oh, another A. We don't necessarily need it, but we could take it because that gets us to C. So we take 2 more A's. Finally, we get our C. So now we have 2 C's. Now we have 2 A's, 2 B's, 2 C's. And that took us a total of 5 minutes to get all of these. 3 on the left side, 5 on the right side. And that is to get all of our characters. So our goal is to find an efficient way to do this. And the most efficient way to do this is a sliding window technique. So, our approach. We're going to count the total of characters. First, we'll count how many A's, B's, and C's are in the string. This is going to give us a baseline because if there aren't enough of each, say we have less than k amount of A's, we can return -1 right away. Next, we're going to check the feasibility, which is if there's less than k amount of each letter, we'll return -1. And then we'll implement the sliding window technique. So our sliding window is going to find the largest contiguous, meaning it goes every member of the subarrays in a row, that we can safely remove while still leaving at least k of each character outside the window. We're then going to calculate the result. So we're going to calculate the number of characters we need to remove. So n minus max window, or max window is the size of our largest valid window, we can remove from our starting array to leave k amount of each letter within the array. So let's go ahead and jump into, or I could draw this up real quick. So we have this array, and we are going to find the longest substring that we can remove from this array to leave 2 of each character still in the array. So initially, the length of this array is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in length, right? And we're going to look. So we have 2 A's here, a B, a C, our last B. So these are the characters that we need. So our longest possible subarray that we can remove is right here, the 4 A's in the middle. So what we're going to do is we're going to do 12 minus our 4. That gives us 8. And 8 is the output. That is our solution. So that's the approach we're going to take to solving these problems. So for the code, first thing we're going to do is initialize an integer array called count. This is going to be a new integer of length 3. And this is simply going to keep track of the count of each of our characters. We'll then also have an integer n, which is going to just be equal to s.length for us to keep it in a variable. So we're going to count the total occurrence of each character. So for each character C in our s.toChar array, we are going to check count of C minus A is going to increment. What does this mean? So count of C minus A is basically going to take the bitwise sorry, I mean the binary representation of each letter, convert it to our 0, 1, 2 that we initiated in count, and it's going to increment those. So if we have an A, it's going to increment 0. If it's a B, it's going to increment 1. If it's a C, it's going to increment 2. So after we count each character and ensure, we're then going to check if we have enough characters. So for each integer I is equal to 0, as long as I is less than 3, I can increment. If our count of I is less than k in any of our letters, we can simply return -1. So we can do this with no worry, considering that we only have 3 characters to worry about. It's not going to be a ton of characters, numbers, uppercase, lowercase. It's just 3 characters, so this is relatively efficient. Next, if we pass that for loop, meaning that we have enough numbers to satisfy the requirements, we can then use our sliding window. So we're going to initialize our window as an integer array. We'll call it window, and it's going to be a new integer of length 3. Integer array of length 3. We'll also have our integer left is equal to 0, and our max window will also be equal to 0. Next, we are going to find the longest window that leaves k chars outside. So for each integer, we're going to call them right is equal to 0. As long as right is less than n, right can increment. That is going to be the right side of our window. Left is going to be the left side of our window. The reason we're using window as a character array is that is going to keep track of how many of each letter, A, B, and C, are in the current subarray that we're looking at. And as long as there is a valid amount or a k amount of each letter outside of that subarray, it's a valid subarray for us to remove. We will be able to update our max window. So window of s.char at right is going to minus the binary representation of A, giving us either a 0, 1, or 2. And that's it. That's all we need for that. That's updating the character. We're incrementing it by 1. Then we will shrink window if we take too many chars. And we're going to do this by moving our left pointer in. So while our left pointer is less than or equal to our right pointer, and this is going to be a little bit of a long one, so we'll go to the next line. And our count of 0 minus our window of 0 is less than k, or our count of 1 is minus our window of 1 is less than k, or our count of 2 minus our window of 2 is less than k. So those are our 3 possible cases. Then we're going to say, hey, window of s.char at left minus the binary representation of A. We're going to decrease u by 1. We're going to get rid of whatever character is there. We'll increment our left pointer and basically shift our window over 1 on the left-hand side. So if we're in this position, let's just say we're here, we're going to say, hey, we have too many A's. There's not enough A's to make a length 2. So we're going to take our A and move it here. Or take our left pointer and move it here. Oh, we still don't have enough, so we're going to take our left pointer and move it here. Simple as that. And these are our 3 possibilities. If we have too many A's, too many B's, or too many C's within our window, we're going to remove them. Finally, we can update our max window within our for loop. So max window will be equal to math.max of max window right minus left plus 1. That is going to be the size of our window, and the reason we're adding plus 1 is because it's going to be a 0-indexed array. Then we can return our n minus our max window, because remember, n is our total length of an array. So if our total array length is 12, and we could get rid of 4 characters, leaving k amount of each character still in the array, then the output is what our answer. So that's our max window. This is our n. Subtract 12 minus 4, we get 8. That is our answer. So if we run this, that passes our test cases, and if we submit it, passes all solutions. Thank you. Follow for more daily LeetCode solutions. If you want to learn how to code, check out the link in my bio. I have a Discord that provides you with all the resources you need to learn to start learning to code right now. Get ahead of your classmates, get ahead of your coworkers, and just have fun. Thank you. See you tomorrow.